Welcome back to the second of our three topics on derivatives. This one, we're going to be looking at the derivatives of exponential and logarithmic functions. And so, we will start out with exponential functions, and these don't work with power rule. The power rule, it does not apply here. But we can still go back to the definition. So if we start out with f of x equals a to the x, just some random number to the x power, we can plug it into our limit definition. So the derivative will equal the limit as h goes to 0 of f of x plus h minus f of x over h, which when we plug it in, we get limit as h goes to 0 of a to the x plus h, the exponent changes, minus a to the x over h. We can simplify this, a to the x plus h, when we add exponents, that would be multiplication, right? X squared times x cubed is x to the fifth. So we could rewrite that a to the x times a to the h. And hey, we have an a to the x in both places. So we could factor that out. And since a to the x doesn't have an h in it, the limit isn't going to be affecting that. So we can actually pull it out of the limit entirely. Now we're looking at the limit of a to the h minus 1 divided by h. And we can do this several different ways. Right now we could look at this graphically if we wanted to. There's mathematical ways, but it's beyond the scope of what we're doing to figure this out. But if you do look at it graphically, you'll see that this, the limit as h goes to 0 of a to the h minus 1 over h, actually comes out to be the natural log of a, randomly enough. And so this says that if we have a function, something to the x, then the derivative is going to be that same something to the x times the natural log of a, the natural log of that something. Interestingly, if we do e to the x, right, e is a natural number. It's my second favorite irrational number, and you'll see why here, why it's so fun, so much more interesting than pi. E to the x, it's going to be e to the x times the natural log of e. What is the natural log of e? The natural log of e is 1. So the derivative of e to the x is just e to the x. It is its own derivative. Any point along the slope of the graph, or of any point along the graph of e to the x, the slope is the y value. How cool is that? Anyway, doing these problems, they start out really easy. We have 2 to the x. Just plug it in. Well, it's 2 to the x, so it's going to be 2 to the x times the natural log of 2. Done. How about 3 times 5 to the x? Well, this 3 isn't a product rule question because the 3 doesn't have a variable. It's just a constant. It's going to go along for the ride. So we're going to have 3 times 5 to the x, natural log of 5. What you do not want to do is you do not want to multiply those to give you 15. That would be wrong. If you really wanted to find natural log of 5 as a decimal, you could multiply that to 3, but I would recommend just leaving it like it is. How about the derivative of e to the x? That's just e to the x. We can get into product rule and stuff. So x squared times 2 to the x. So we want to get our u's and our v's. So u is just x squared. V is 2 to the x. The derivative of x squared is 2x. The derivative of 2 to the x, we just saw over here, is 2 to the x natural log of 2. Then we can multiply the diagonals and add them together to get x squared times 2 to the x natural log 2 plus 2x times 2 to the x. You could factor 2 to the x out of here if you wanted to, and an x really if you wanted to, but nothing's going to come from that, so I wouldn't bother. And we can also use chain rule. All the stuff we learned last chapter still applies. E to the x squared. So e to the something is just going to be e to the something, e to the x squared, times the derivative of the something. What's the derivative of x squared? It's 2x. So whenever we have something to a power, we're going to end up with that in the answer, and then times the derivative of that thing. And so that's exponential functions. It just follows a little formula. Logarithmic functions, again, will follow a little formula. We're not going to figure this out mathematically today. We'll see why this is true tomorrow. But right now, if you have a log base b of x, the derivative is going to be 1 over x times the natural log of that base. So being that logs and exponentials are opposites of each other, they're inverses of each other, we multiply by the natural log for exponentials, we divide by the natural log for logs. And so we have that. We were talking about e for exponentials, so let's think log base e. Log base e is natural log, so if we have the natural log, the derivative will be 1 over x times the natural log of e, which is 1. So the derivative of natural log of x is just 1 over x. You think that, well, that's x to the negative 1. If we do the antiderivative, that would be x to the 0, but we'd have to multiply by 0, so it would be 0. It doesn't work. It's natural log of x. So some examples of this. Y equals log base 7 of x. Just right up here, put into the formula. 1 over x times natural log of 7. Natural log of x is just 1 over x. Yeah, that's boring. But what if we have natural log of 2x? Let's do some chain rule. Natural log of 2x is going to be 1 over 2x times the derivative of 2x, which is 2. We can cancel those to get just 1 over x. Well, that's the same as this. If we remember our log properties, the multiplication, this could be natural log of 2 plus the natural log of x. Natural log of 2 is a constant. It becomes 0. And so you have just plus the derivative of natural log of x, which is 1 over x. Oh, these should be y primes. These are derivatives. So is this one. The same deal, what if we have natural log of x squared? It's going to be 1 over x squared times the derivative of x squared, which is 2x. We can cancel, and x cancels, so we get 2 over x. Remembering our log properties, we could take this 2, move it out to the front, so we have 2 times the natural log of x. Derivative of natural log of x is 1 over x. 2 times 1 over x is just 2 over x. So the log properties still actually work, and you can do those first. You could just go through and do chain rule. It doesn't matter. Sometimes one of them might be easier than the other, though. So let's look at some more. Product rule with these. E to the x times natural log of x. We get the u's and the v's. U is e to the x. V is natural log x. And then the derivative of e to the x is e to the x. The derivative of natural log x is 1 over x. And we can multiply and add them together to get e to the x natural log x plus e to the x times 1 over x, which is e to the x over x. So nothing's changing with the product rule here. It's just more practice using it along with what we're just learning. How about x times natural log of x? Same thing. There's nothing really weird here. You could pause it for a second if you'd like to, and you can try this out real quick. All right, so we get our u's and our v's. X is u, natural log x is v. Derivative of x is just 1. Derivative of natural log x is 1 over x. Cross multiply, we get natural log x times 1 plus x times 1 over x, which is x over x, which simplifies to natural log x plus 1. We could also use quotient rule. Natural log x over e to the x. Get u's and v's. U is natural log x, v is e to the x. Derivative of natural log x, 1 over x. Derivative of e to the x, e to the x. We can multiply and subtract. So we have e to the x over x minus e to the x natural log x, and then divide by the denominator squared. E to the x squared can just be e to the 2x. You can leave it like this. You could also factor out an e to the x and cancel if you wanted to, and it could be simplified to 1 minus x natural log x over x e to the x, but I would just leave it right like that. Anyway, that would be logarithmic derivatives. I hope you have good notes and that makes a little bit of sense. It's just a couple formulas using what we've done in yesterday and last chapter. And I will see you in class.